Welcome to Einstein's Mechanics. In this episode, we are going to solve the second example on eigenvalues and eigenvectors for a 3 by 3 matrix. So we have the question, find the eigenvalues and corresponding eigenvectors of the matrix A given. So we have the matrix and we have to find the corresponding eigenvectors for the eigenvalues we will obtain for the matrix. So straight away, let's look at how best we can do it. So we start with the eigenvalues, and we know that to find the eigenvalues, we are going to find the determinant of the matrix A minus lambda I equal to 0, where each of the symbol has its usual meaning. The lambda is the eigenvalue and I is the identity matrix. A is the matrix given. So first, let's find an expression for the matrix A minus lambda I. And that is going to be, we have the matrix A to be 8 minus 6, 2, negative 6, 7, negative 4, 2, negative 4, and 3. Minus lambda, the identity matrix, 1, 0, 0, 0, 1, 0, and 0, 0, 1 as the identity matrix. So an expression for the matrix A minus lambda I is going to give us 8 minus lambda negative 6, 2, negative 6, 7 minus lambda and negative 4. We have 2 negative 4, 3 minus lambda. So this is an expression for the matrix A minus lambda I. So in order to find the eigenvalue, we must find the determinant of this matrix A minus lambda I and equate it to 0. So here, let's look at how best we can find the determinant. So I'm going to consider the first column and use it to find the determinant. So that is going to give me my 8 minus lambda going to multiply the 2 by 2 matrix left, that is going to be 7 minus lambda negative 4, and we also have negative 4, 3 minus lambda, minus 6, the 2 by 2 matrix, that is going to be negative 6, negative 4. We also have 2, 3 negative lambda. Then plus 2, the 2 by 2 matrix, that is negative 6, 7 minus lambda. We have 2 and negative 4. So with this, we can further reduce this. So let's equate it to 0. We can further reduce this to 8 minus lambda multiplying the determinant of the 2 by 2 matrix. That is going to give us 7 minus lambda multiplying 3 minus lambda minus negative 4 multiplying negative 4 for the first part. So the second part, that is going to be plus. This is a plus because negative 6 will give us plus, and that is going to be 6 multiplying the determinant of the 2 by 2 matrix, that is going to be this form, minus 2 by negative 4. Then the last part, that is plus 2, and that is going to give us this as the determinant of the 2 by 2 matrix, 7 minus lambda, this way. Are you okay? Equal to 0. So if you reduce this further, you are going to get 8 minus lambda, the first bracket. If you open it, you are going to get 21 minus 7 lambda minus 3 lambda plus lambda square plus 16. That's negative 16. Negative 16. Like this. Now we come to the second bracket, plus 6 multiplying negative 18 plus 6 lambda plus 8, plus the third one, that is going to be 2 multiplying 24 minus 14 plus 2 lambda equal to 0. So let's further reduce this and see what equation we are going to have. Are we okay? So here we are going to also reduce that. So when you reduce the equation further, you are going to have 8 lambda squared minus 80 lambda plus 40 minus lambda cube plus 10 lambda squared minus 5 lambda plus 36 lambda minus 60 plus 4 lambda plus 20 equal to 0. And your final equation, when you group like terms, you are going to get the equation as lambda cube minus 18 lambda square plus 45 lambda equal to 0. So this is our equation where we can find the roots of the equation. Are we okay? So this is a cubic equation, and when you find the root of this equation, your lambda should be equal to 15 and your lambda should be equal to 3 and your lambda should be equal to 0. Are we okay? So these are the roots of the equation which represent the eigenvalues. So therefore, the eigenvalues for the matrix or for the given matrix are, we have 15, 3 and 0. So now for each of the eigenvalues, we are going to find its corresponding eigenvector. Are you okay? So let's try and see. So we start with when lambda, the eigenvalue is 15, what is the corresponding eigenvector? And we are going to obtain that from the expression lambda I multiplying the vector equal to 0. Now we know the expression for A minus lambda I, and that is going to be, we have the equation, what we root for, that this is 8 minus lambda minus 6. We have 2, and this is also going to be negative 6, 7 minus lambda, negative 4. 2, negative 4, 3 minus lambda. Let's call this first eigenvector as x1, y1, and z1. Everything is equal to 0. Now, if we put in the value of lambda to be 15, we are going to simplify this equation or this matrix to negative 7, negative 6, 2. This second row, that is negative 6, negative 8, negative 4. 2, negative 4, negative 12. We still have our x1, y1, and z1. Everything is equal to 0. Trying to use the elimination method to find the corresponding vector. I'm going to combine the matrix with, so that's negative 7, negative 6, 2 should be equal to 0. Negative 6, negative 8, negative 4 to 0. 2, negative 4, negative 12 should be equal to 0. So I'm going to start with my row operations such that I can find it easily. This matrix looks quite unfamiliar because the negatives are too much, so you have to pay attention. So let me start with my row operations of the matrix. Let's look at what I will do. So because of the negatives, I will try to take them all out. So row 1, I'm going to multiply through by -1 of row 1. Row 2, I'm going to multiply by -half of row 2. And row 3, I'm going to multiply it with half of row 3. So meaning if I multiply through by negative, row 1 is going to be 7, 6, -2 to 0. Row 2, that is going to give me 3, 4, 2, 0. And half of row 3, that is 1, -2, -6 to 0. This way. Because I have 1 here, I would like to swap row 1 and row 3 such that everything, the 1 will come here and my analysis will be simple. So now we swap row 1 and row 3. Once we swap them, the analysis is going to be 1, -2, -6 into 0. Row 2 is going to remain the same, 3, 4, 2, 0. And 7, 6, -2, 0. This way. Now at the third part, I will try to perform an operation to turn this and that to 0 to help me write an equation to find x1, y1, and z1. So on row 2, I'm going to say 3 times row 1 minus row 2. On row 3, I'm going to say 7 times row 1 minus row 3. So row 1 is the same, 1, -2, -6, 6, 0. When you perform this formula on row 2, you are going to get 0, -10, -20, 0. And on row 3, that will be 0, -20, -40, 0. You can pick any of the equations, that's row 1, row 2, or row 3 to now write your final answer. So from row 3 or from equation 3, I can say -20y1 minus 40z1 is equal to 0. And this means that 20y1 should be equal to 40z1. And when you make y1 on z1, that is going to be 40 on 20. And that is going to give you, this supposed to be a negative here. Yes, once it crosses the equal sign, it becomes positive. You divide through by negative, that is going to be that, negative that. And this is going to be -2 on 1. This means that my y1 is -2 and my z1 is 1. From the first row, I can write an equation such as x1 minus 2y1 minus 6z1 equal to 0. And when you put in the values of y1, which is -2, -6z1, which is 1, equal to 0, your x1 should give you +2. Therefore, the corresponding vector x1, y1, z1 is going to be 2, -2, and 1. That's for lambda is equal to 15. Are we okay? So now we have 2 more to go. Let's see what will be when lambda is equal to +3. What is the corresponding vector? So now for the eigenvalue at 3, what is the corresponding vector? The same approach, we have our A minus lambda I, the vector equal to 0. The expression for A minus lambda I is giving us 8 minus lambda -6, 2, -6, 7 minus lambda -4, and we have 2, -4, 3 minus lambda. This is the second part. So I'll call the vector x2, y2, and z2. Everything is equal to 0. So now let's put in the value of lambda to be 3, and our corresponding matrix is going to be 5, negative 6, 2, negative 6, 4, negative 4, 2, negative 4, 0, multiplying x2, y2, and z2 equal to 0. Quite simple now. So we'll start with the elimination and we will see how to go by it. So I'll combine, so the elimination starts. I'll have to write it 5, negative 6, 2 into 0, negative 6, 4, negative 4 into 0, and 2, negative 4, 0 into 0. Now I would like to multiply equation 2 or rule 2 by half of rule 2, and on rule 3 I also say half of rule 3, meaning rule 1 is the same, which is 5, negative 6, 2 into 0. Then rule 2, that is going to be negative 3, 2, negative 2 into 0. And rule 3, that is 1, negative 2, 0 into 0. Since I have 1 here, I would like to swap rules so that the analysis will be so easy. So I would like to swap rule 1 and rule 3. So swapping rule 1 and rule 3, that is going to give me 1, negative 2, 0 into 0. Rule 2 is intact, that is negative 3, 2, negative 2, 0, and 5, negative 6, 2, 0, this way. Now to make this 5, 0 and this negative 3, 0, I would like to perform an operation which says I'll multiply 3 times rule 1 and plus rule 2, and also 5 times rule 1 minus rule 3. So rule 1 is intact, 1 minus 2, 0 into 0. And when you perform this equation on rule 2, this is going to be your answer, 0, negative 4, negative 2, 0. We still have 0, negative 4, negative 2, 0. So now that you have this, you can write an equation from any of them and do your analysis. So let's look at it. Now from equation 2 or rule 2, can I write negative 4y2 minus 2z2 equal to 0? This means that my 4y2 should be equal to negative 2z2, and y2 on z2 should give me negative 1 on 2. This implies that my y2 is negative 1 and my z2 is positive 2. From rule 1, I can write an equation as x2 minus 2y2 equal to 0, because the z part is 0 already. So I can put in the value of y2, that is 2 minus negative 1 equal to 0, and x2 is going to give me negative 2. Therefore, the corresponding eigenvector when lambda is equal to 3, that is going to give me negative 2 for the x, the y is negative 1, and the z is positive 2 for lambda is equal to 3. Now we have the last one to perform the operation when lambda is equal to 0, or when the eigenvalue is 0. What is the corresponding vector? So it also follows the same pattern. We look at 4. Lambda is equal to 0. We are also going to start from the same lambda I the vector is equal to 0. Now the expression is going to be, we still have our 8 minus lambda negative 6, 2, our negative 6, 7 minus lambda and negative 4, 2 negative 4, 3 minus lambda. This is the third part, so my vector will be x3, y3, and z3. Everything should be equal to 0. Now, if I put in the value of lambda equal to 0, I'm going to get the matrix 8, negative 6, 2, and negative 6, 7, negative 4, 2, negative 4, and 3, multiplying x3, y3, and z3 equal to 0. Let me start with the elimination. And I'm going to get this 8, negative 6, 2 going into 0. Negative 6, 7, negative 4 going into 0. 2, negative 4, 3 going into 0. Are we okay? So I'll start with the rule operations. Here, I want to multiply row 1 by half of row 1, and row 3, I also do half of row 3. So this is going to give me 4, negative 3, 1 going into 0. Row 2, that is going to be negative 6, 7, negative 4, 0. And row 3, that is going to give me 1, negative 2, 3 on 2, 0. So now I have 1 here. You know what to do? I'll swap row 1 and row 3. So in my next analysis, I swap row 1 and row 3. This is going to give me 1, negative 2, 3 on 2 going into 0. Row 2, negative 6, 7, negative 4 into 0. And the row 3 is going to be 4, negative 3, 1 into 0. In order to reduce this, I'm going to say row 2 is 6 row 1 plus row 2. I want to get this negative 6 to 0, this 4 to 0. And row 3 should be 4 row 1 minus row 3. This is 1, negative 2, 3 on 2 into 0. And when you perform this, we are going to get 0, negative 5, 5, 0. The same thing, 0, negative 5, 5, and 0. So now you have to write your equation to fish out the vector. So from row 2 or 3, I'm going to say my equation should be negative 5 y3 plus 5 z3 equal to 0. This means my 5y3 should be equal to 5z3, and y cubed or y3 on z3 should be 1 on 1. This means that my y3 is 1, my z3 is 1. And from row 1, the expression s3 minus 2, 2 by 1, and plus 3 on 2 by 1 equal to 0. Therefore, x3 is equal to half. Therefore, for lambda is equal to 0, its corresponding eigenvector and z3 is, we have half, 1, 1. And that's that. Thank you for watching this episode. Check out for the next episode.